Meet Alex Apili, the physics oracle. For over 20 years, he has ignited minds and shaped future through the power of physics, from bustling classroom in Kaduna to quiet labs in Benin City. His teaching have echoed across Nigeria, transforming students into scholars, thinkers, and innovators. His secret, a rare gift of making the complex feel simple. To his students, equations become stories, and theories become tools for transforming the universe. Alex Apili isn't just a teacher, he's a mentor, a guide, a legend in the world of science education. Across Nigeria, those who once sat in his classroom now lead in tech industries, research, and education, all carrying forward the legacy of the physics oracle. Alex Apili, inspiring minds, shaping destinies, one lesson at a time. At the end of these lessons, the student should be able to: one, distinguish graph; two, choose scale and do mathematical calculations in between the scale; three, plot points; number four, draw the line of best fit; and number five, calculate the slope of the graph and take intercept; and number six, do deductions from graph. See you there. This is the table of values from the experiment on the experiment vertical oscillation. Now, from the table generated, we have m in gram, t in seconds, t2, t in seconds, and also capital T seconds and t squared. M in gram, we are given 50 gram, 100 gram, 150, 200, and 250 gram respectively. And we carry out the experiment, repeating it twice. That is what T1 and T2 represent. Of course, from the first experiment, when we did with 50 gram, we had 8.50 first time, and second time 8.00. When we took the average, we have 8.25 seconds. Of course, to obtain T, we use the formula T equals to T over N, where T is time and N is number of oscillation. We are given 10 oscillation. So when you divide 8.25 divided by 10, you obtain 0.825. And when you square this value for T squared, you obtain 0.681. So we repeat the procedure for 100 gram, 150 gram, 200 gram, and 250 respectively. So we'll now go to plot the graph. In the graph plotting, our content will be as is distinguished, so we'll take the as is distinguished. For us to distinguish the table, the first thing we do, we take a box out. Remember, a box is equal to 2 centimeters. So we'll take a box out. And remember, in this, your exam, you're supposed to use pencil or through in the graph. So we'll take a box out on the vertical, a box equal to 2 centimeters, and also a box out on the horizontal. Now, why a box out on the vertical and a box out on the vertical? Because all our values, the values obtained from the experiment, they are all positive. They are all positive values. The values obtained from the experiment, they are all positive values. So we have done that. Remember, we are expected to plot a graph of T squared on the vertical axis against M on the horizontal axis, starting both axes from the origin 0, 0. So we indicate, having distinguished the axes, we have to indicate. So for the vertical axis is T squared in seconds, and also the horizontal axis is what? M in gram. So we have succeeded in distinguishing the houses. So the next thing we do now is to take your scale. Now the next thing is what? We are taking the scale now. We want to take our scale, that's the content. So we take our scale. Now in taking the scale, remember we are expected to plot t-square on the vertical against m on the horizontal. So what we'll do, let's start with the m. Let's take the scale for m. You take the scale for m. First of all, the highest value 50, 100, 150, 200, and 250. The highest value here is what? 250. So we circle. Now we are expected to take values. Now in spreading that scale, remember that we have odd numbers, which are 3, 5, 6, 5, 7, 5, 7, 9, then 11, and so on. Then we have even numbers. Even numbers, we have 2, 4, 6, 8, 10, and so on. Then we have neutral or unity. We have just one. So remember, in choice of scale, all numbers are prohibited when used, so it will be wrong. So you can only use even numbers and neutral numbers. Now recall, we are expected to spread 250. The highest value on our scale is 250. The highest value on our scale is what? 250. So we are expected to spread these 250 on the horizontal. So count the number of buses available. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. So how do we spread 250 grams into 9 buses? Each of the buses is 2 centimeters each. So what do? We start by let's use, for example, 2 centimeters, which represent the big bus, is equal to, if we start with 10 grams, for example, we say, okay, from 0, we say 10, 20, 10, 20, 30, 40, 50, 60, 70, 80, 90. And we are expected to put this, in our just 9 buses. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's far less than what? 250. It's far less than 250. So that scale will not work. So let's try 2 centimeters to what? 20 grams. So we can have 20, 40, 60, 80, 100, 120, 140, 160, 180. So it's still far less than what? 250. Remember, we are dealing with the highest value 250. So at this point, instead of, if you are using 40 will give you multiple calculations. This is, you are using a square size boxes. So it is good. Let's use 50. Let's use 50. In other words, 2 centimeters to 50 grams. So we can have 50, 100, 150, 200, 250, 300, 350, 350, 400, 450, that's 500. So let's stop there because you have exceeded the 250, that is the value. So we can spread this. How many value do you have? How many buses do we have available on your vertical scale? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 550. So it's far exceed your 250. So at this point, we record it. At this point, we record. So we have 50 from 0. Remember, here is 0, 0. We have 50, 100, 150, 200, 250. Oh, we are on, remember, we are working on what? on M houses. We are working on what? M houses. So we're supposed to record for M, not T houses. You have 50, 100, 150, 200, 250, 300, 350, 400, they have 450. Value here is by decimal places, the highest value is 0.632. But when dealing with plotting a graph, we don't look at the decimal value, but we look at the numbers, the value in terms of the number. Here, the highest value here in terms of number is 922. So we are going to divide the number of spaces available into 922. So we'll count the spaces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 spaces. So what we do now, again, remember, I'll say 2 cm, 2 centimeter, which is a very big box, is equal to, we're using, let's use 0.1 for example. That means 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Remember 1.1. We have 11 boxes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is that. So meaning that, so we have to interpret this information right now in our square boxes. So we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, 1.1. So we have interpreted on our square boxes. So that is that. Now we have succeeded in taking our scale. We have to indicate now on M houses, we have 2 centimeter is equals to what? 50 gram. Then on T square houses, we have 2 centimeter is equal to 0.1 second. So we have indicated on top of our graph. So that's the scale. Then the next item in our content now is we are looking at, we have taken our scale, right? Okay, taking your scale, we have taken our scale. Then on scale calculation, let's quickly do that. Calculation. On scale calculation, so we look at the little mathematics in within the scale. Now, what does that mean? It means that on the horizontal axis, we have 50 is grown by 50. That means there are the little boxes between 0 and 50 is 10. So to get the value for each of the little boxes, we have 50 divided by 10. So each of the boxes is what? 5. So that's the little scale calculation. Why? For the vertical axis, the box is 0.1. So to get the value for each of the boxes, 0.1 divided by 10. That will give you 0.01. So that is that for vertical axis. So we have done the scale calculation. Then we now go to the next program, that's point plotting. So we are going to plot our point. Let's go back to our table. So these are our table of values. So we'll take them one by one. So we are taking the first one, which is 50 against 0.681. And before you begin to plot this point, note that when dealing with for M axis, they are whole numbers, so we don't have a problem with that. Then when dealing with decimal point, in this case 3 decimal places, you have to work up to 2 decimal points. The last value should be approximated. When it's up to 5, approximate it to the second number. If it's not up to 5, you discard it. So let's start. 50 on M axis against 0.681. So we'll come to 50 on our graph. So we'll trace it to 6. So we'll trace it to 6, that's 6. Remember, that's 0.6, and it's, each of the bus is 0.1. So you count 8 buses. 1, 2, 3, 4, 5, 6, 7, 8. So you mark the 8 bus. So you dot it. Now we have dotted the 8 bus, but for clarity, you draw a circle around it. So that's for 50 gram against 0.681. Then the next one is 100 gram against 0.7. So we have 100 gram. So go to 0.7, and that's 0.7. Remember, 4 is not up to 5. So you call it, you discard it. It can be 0.71. Each bus is just 1. So we dot a bus after 7. So we have dotting a bus now after 7. That's 0.71. Again, for clarity, we just circle it. For clarity, we circle it. Then also 150 against 0.922. The third number there is 2. It's not to 5, so you discard it. It's not be 0.92. So we come to 150 up to 0.9, and that's 0.9. 2 is 2 buses, 1, 2. So we dot, so that's it, we dot so for clarity, we circle it. So the dot represents the point. Then again, for 200 against 0.632. So that's 200 against 0.632. Then that's 200. So we trace it to 6, and that's 6. Then 0.3, 2 is not up to 5, discard it. So you count 3 boxes away from 6.6, 1, 2, 3. So you dot it. So we have dotted for clarity with circle. So the last experiment is 250 gram against 0.681. 1 is not up to 5, discard. So come to 250 against 0.6. Now 0.6 there. You count the 8 balls. So that's the 8 balls. Count 1, 2, 3, 4, 5, 6, 7, 8. So that's the 8 balls. So you dot it. So we have dotted the 8 balls with circle of visibility. So we have succeeded in taking all our points. We have succeeded in taking all our points. So the next content now is what? We will take the line of best fit. Line of best fit. The line of best fit is a line drawn across, a straight line drawn across the points. Minimum of 3 points. But peradventure you have only 2 points you can draw. But the distribution will be such that some point up and some down, evenly distributed. But in this case, we have to go back to what we were told. They said we should determine the slope S and intercept C at the vertical axis. In other words, your line of best fit is going to touch the vertical axis. So you have to draw your line such a way that it will touch the vertical axis. I think the best option now is to connect these two. We connect these 2 points. We connect these 2 points. We connect these 2 points. So we are connecting these 2 points such that, so we are connected 2 points. You can see it's evenly distributed now, 2 down and 1 up, and they are just 5 points. So we have taken our straight line, which is the line of best fit. So we're taking our straight line, which is the line of what? Best fit. We are done with our line of best fit. So the next item now is what? Our slope. So we're going to take a slope. A slope usually what? The remaining side of a triangle drawn to your line of best fit. You know, you can see this one now. This is your line of best fit with the point. You see, you can see that the remaining side of the triangle, that helps you to get a very big triangle that will enable you to estimate for your slope. So let's do that. So when I draw my slope, I draw it such a way that I draw the line on top of a very big line, thick line, and draw it on top of a thick line. So that's on top of the thick line. Then I'll connect the line. Yes, so I'm connecting it now. The basics. So right now, I'm going to label. We have here X. So I'm going to label the triangle right now. Here we're going to have Y2. Here X, Y1. Here I have X2. Sorry, X1. Because as it's proceeding to the right, it increases X1. And here's what? X2. So why am I using Y1 and Y2? Because it's easier for you to memorize. So it's easier for you to memorize. So let's see that. So it's easier for you to memorize. If I have slope S is given by change in Y over change in what? X. So that's slope X. Now our vertical axis is t square. I can say it's equal to what? Change in t square over change in what? In N. So if this is equal to this, so we can use that y2 minus y1 over x2 minus x1. So let's find out the value for y2. So from the graph again from the graph, my y2, I'll trace it. I'll use the meter rule to trace it. So I'll trace, that's the height of the triangle. I took the end of the triangle here. So I'll trace it to the vertical. So I'll trace it to the vertical. When I trace to the vertical, so it becomes 0.91. So my y2 is 0.91. So y1 again is where the remaining side of the triangle touches the vertical axis, and that will be, it's already on a thick line. So that will be 0.61234. So that is 0.634. So my y1 is equal to what? 0.64. 0.64. So I've got my y1. So my x2, so I'll trace this down to the horizontal half. So when I trace it down, so it fell on 400. So my x2 is 400. So my x1 adjacent side here touches the you can see it touches the line exactly at 0.6, exactly at 0.64. But I have to trace it to S as if I trace it, that's the 0 mark, so it fell at the 0. So my x1 is what? At 0. So with this value now, I will substitute into the formula. So slope S is equal to y2 is what? 0.91 minus 0.64 all over S2 is 400 minus 0. So let me evaluate. So when you evaluate, you have 0.27 over 400. So when you evaluate 0.27 divided by 400, our value is 6.75 exponential minus 4, all times 10 to the power minus 4. So that will become our answer. So what's our intercept C? So intercept C is given by, so the intercept is obtained, the intercept is where your line of best fit touches the vertical axis. And that is exactly the same point as what your y1, and that's 0.64. So that intercept is what? 0.64. So that's your intercept. You can indicate it intercept. That is equal to 0.64. So the next, our next question says we should determine the period T when M equals to 180 gram. We should determine the period T when M equals to what? 180 gram. So you locate 180. You locate 180. 180. Remember, each of these balls on the horizontal is growing by 5. So 5. So every 2 balls is 10. That's 160, 160, 160, 170, and 180. So the 180 at point 180, you trace it. So at point 180, you trace it to your line of best fit. So you trace the line of best fit. So when you get to the line of best fit, so you connect it again from there. You trace it to your vertical axis. So you connect it to your vertical axis. So where it touches the vertical axis, that becomes the value of T. So we have 0.7. Each of the balls is 1, 2, 3, 4, 5, 6. So 0.76. So when M is equal to 180, so T square is equal to 0.76 seconds, 180 gram. So that's the end of this section. So this is the graph so far, and that's the end of this section. So I'll see you again in our next lesson. Provided with a meter rule, a clamp, and a set of masks. 1. You have been provided with a meter rule, a clamp, and a set of masks. Roman figure 1. Clamp the meter rule to the edge of the You have been provided with a meter rule, a clamp, and a set of masks. Roman figure 1. Clamp the meter rule to the edge of the bench such that 90 centimeters of the rule project from the edge as shown in the diagram above. Ensure that the rule is capable of performing oscillation motion. Number 2, Roman figure 2. Use a mass of M equals to 50 grams at the free end of the rule. Roman figure 3. Deflect the rule such that it performs vertical oscillation. Deflect the rule such that it performs vertical oscillation. Roman figure 4. Determine the time T for 10 complete oscillations. Roman figure 5. Calculate the period T of the oscillations and evaluate T square. Roman figure 4. Repeat the procedure for 4 other values of M equal to 100, 150, 200, and 250 grams. In each case, determine and record the corresponding value of T, that's small letter T, period, T, that's capital T, and T square. Full stop. Tabulate your reading. Roman figure 7. Plot a graph of T square on the vertical axis against M on the horizontal axis. Starting both axes from the origin. Bracket to both 0, 0, bracket close. Roman figure 8. Determine the slope S of the graph and its intercept C on the vertical axis. Roman figure 8. So Roman figure 9. Evaluate K equal to 4 pi over S, where S is slope. Bracket open, take pi equal to 22 over 7, bracket close. Roman figure 10. From your graph, determine the period T when M equals to 180 gram. Roman figure 11. State 2 precautions taken to ensure accurate result. B part of the question. Number 1, explain simple harmonic motion. Number 2, define period and frequency with respect to simple harmonic motion. Now, that is the question read. Now we are about to start the experiment. We're about to start the experiment. Now, again, let's go back to, they said we are provided with what? A meter rule. This is a meter rule. A meter rule is what? 100 centimeters. 100 centimeter what? Ruler. You know, this is popularly known as what? Ruler. But in the laboratory, we refer to it as what? A meter rule. Now, what are the set of masses? Now, the set of masses, they are just 4 of them. We have 50 gram, another 100 gram, then another 200 gram. So these are the set of masses required for this experiment. So we follow the instruction from number 1. So let's start the experiment. Now in the experiment, we are asked to climb the meter rule by 10 centimeter. So climb the meter rule by 10 centimeter. So this is a G clamp. We use the G clamp to do the clamping. So you clamp the meter rule exactly 10. So you clamp it 10 watts, position 10. So clamping the meter rule at position 10 means that 90 centimeter is extended. 90 centimeter is what? Extended. It means that 90 centimeter is what? Extended. So we have succeeded. Now we are told, after clamping the meter rule with a G clamp, you are told to spring the meter rule. We are told to spring the meter rule so that it can perform what? Vertical oscillation. Now, how we clamp this meter rule to the table? Now, before we proceed in this experiment, let's quickly look at what the possible precautions. What are the possible precautions to ensure accurate result? Number 1, Because there is a readable device, there's a readable device called what? A meter rule. Now, since there's a readable device called a meter rule, that's the first point where you draw your precaution. And what is that precaution? You're going to write, I ensure that I take my reading to eye level to avoid error due to parallax. I ensure that I take my reading to eye level to avoid error due to what? Parallax. So what you have to state the device. I ensure that I take my reading to eye level in reading the meter rule. In reading what? The meter rule to avoid error due to parallax. That's the first precaution. Now, the second precaution we can draw from this experiment is that I ensure my meter rule was clamped tightly to the table in order not to jeopardize the experiment. I ensure that my meter is well clamped tightly to the table in order not to jeopardize the experiment. And the last precaution we can take from this experiment is that, the next thing, and when we follow instruction 1, we are going to be asked to what? Place each of the mass at a specific distance to perform oscillation. Now you can see that this mass is very heavy. We need to get a device. You're also going to write that I ensure that the mass is well tightened to the meter rule with the aid of a sellotape or an adhesive with the aid of a sellotape or adhesive to avoid accident. Yes. What kind of accident? If this heavy mass springs like a catapult and hit your forehead, you can no longer continue with the experiment. So it's to avoid accident, because this thing can actually spring it, and it will be the case of Goliath and David. So that is that. So we have drawn 3 experiments. Remember, in your exam, they are going to ask you to write 2. Now, Roman figure 1. Now let's go back to our instruction. In Roman figure 1, we are told, so they say you are provided with a complete meter rule, a clamp, and a set of masses. 1, clamp the meter rule to the edge of the bench such that 90 cm of the rule project from the edge as shown in the diagram above. Ensure that the rule is capable of performing an oscillation. 2, fix a mass of 50 grams at the free end of the meter rule. 3, deflect the rule slightly such that it performs vertical oscillation. Determine the time t for 10 complete oscillation. What? Place the 50 gram mass at the end of the meter rule. So I'm going to use adhesive, sellotape. I'm going to use sellotape. So I'm going to use sellotape to place it. Now you are told to place the mass at the end of the meter rule. Then we take 10 oscillations. So how do you take 10 oscillations? I'm going to raise it up slightly and leave it to what? Go up and down. Up, down is an oscillation. Up, down is what? An oscillation. So these 2 persons, you are going to time me now. Let's start. Let's take the first 10 oscillation. When I say you start at the count of what? 3. 1, 2, 3. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. So we are going to take 2 reading now. What are our time reading now? So for the first timer, look at the timer here. Our timer reads what? It read what? 8.5 seconds. So that's C1, 8.5 seconds. Then what is second timer? What's the reason of that? What Flip, what's your timer? What did it read? Our reading is what? 8.5 seconds for the first reading, and the second timer read what? 8 seconds. So our final reading is going to be the 2 reading. It's going to be what? The 2 reading. T1 plus T2 divided by what? 2. That will give you the average reading, right? 8.25 seconds. So that's our first reading. So we are going to repeat the procedure. We are repeating the procedure for another value. We are repeating the procedure for another what? Value of M. And that will be 100 gram. That will be what? 100 gram. Again, you place the 100 gram at the end of the meter rule. You place the 100 gram at the end of the meter rule. See 100 gram mass at the end of the meter rule, and carry out the 10 oscillations. So let's do that. Are you ready?
Yes.
At the count of 3, remember the time recorder, note that. The second time recorder, note that. And I will take the oscillation right now. I'll take it off slightly. Please don't. It's slight oscillation. Don't try to bend the meter rule until it breaks your hand. So take it up a bit and allow it to what? Flip up and down. Let's go. 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's our recorder? So what's this reading?
8.7.
This is not 8.7. This is 8.9. It's very close to the. It's very close to the line. 8.9. So what is the second reader? What's your reading there? 8 point what? 8. So you take the average time T, that's about 8.4645. Now recall, we are told from other instruction to find T and what? T square. Remember, T is evaluated. T is what? An evaluated value. We use the formula T equals to time over number of oscillations. Yes. Period equals to what? Time over number of oscillations. So you are going to use it to evaluate for T and square the value of T to get the remaining column. So we are going to repeat the procedure for 150. Now, if you are using the 150 gram mass, there is no mass recorded as 150. You are going to join 2 together. And in joining that 2, what does that mean? It means that you are also going to, first of all, you tie the 100 gram mass very well to your meter rule. So that's the first load. After tying your 100 gram mass to the meter rule, now please remember that when you are doing 150, you have to bind the 2 masses together with enough sellotape so that it will not flip off. Let's start. Are you good to go? 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So
No, 8.8 or 8 point.
no, this is more than this 10. This 10 now.
No, 9 point.
No.
Not yet.
Okay, 9 points. This is about 9.2.
Okay, if you add it here, 9 point.
That's 9.2. Now, what about the digital reader? What's your reading?
10.
Okay, right, 10. 10.
Maybe I get another one. Okay.
Where's 200? Give me the big mass. I'm taking the mass. We are repeating it for mass 200. Again, you tie the mass 200 to the edge of the meter rule and take a flip. Are we good to go?
Yes.
Let's take a flip. 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Let's go.
7.9.
Okay, 7.9.
Give me a plus one.
That's 7.9. Can you see the reading there? 7.9. The digital meter rule. Take the flip for 250 miles gram. Okay, let's start. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So
7.5. 7.5. In the lesson ahead, please be prepared to leave in the comment section questions and state area of difficulty. Looking forward to see you there.